Hey guys, welcome back to Math from My Desk. Today I'll be answering question 1 from the AP Calculus AB and BC 2024 FRQs, which have been released today, right? So let's go ahead and start. So the temperature of a coffee in a cup at time t minutes is modeled by this discrete function. We have c as a function of time, degrees in Celsius, and for 0 is less than or equal to t is less than or equal to 12. Selected values of this function CFT is given in the table that is shown, and we want to approximate c prime of 5 using the average rate of change of c over this interval from 3 to 7, so show the work. So this is essentially we also want to include units of measurements. So let's see, we want to find the average rate of change, and we want to find the units of measure. So this is essentially the slope, right, because we're given CFT. So, and it's asking us to approximate. So m is equal to y2 minus y1 over x2 minus x1. This is the formula for slope, right? So this is our y, right? And this is our x. And from 7 to 3. So we're going to do 69 minus 85 over 7 minus 3. And this is equal to, this is a calculator active question. So you are allowed the use of a calculator throughout these two problems, the first two problems. This is -4. And we want to have the units of measurement. So c prime of 5 is going to be the rate at which CFT is changing. So the rate at which the degrees is changing, which is simply degrees Celsius divided by minutes. So degrees Celsius per minute. So I would put this as my answer, and I'd feel pretty confident about it. So now let's move on to the next question. So we want to use a left Riemann sum with the three sub-intervals indicated by the data in the table to approximate the value of the integral from 0 to 12 of CFT dt, and we want to interpret the meaning of that integral divided by 12 in the context of the problem. So let's go ahead and first evaluate the Riemann sum. So we want 3 equal sub-intervals, so this would be here. So we have 3, we have 4, and we have 5, right? We have a rate of change, a change of 3, a change of 7 minus 3 is 4, and 12 minus 7 is 5. So this is a left Riemann sum, so we would go to the left here. So we'd get 3 times 100 plus 4 times 85 plus 5 times 69. And this is an approximation rate. So we're going to go ahead and plug this into our calculator. I'm not sure if the College Board would require you to do this. Sorry here. So we have 985. I don't think we need units. It's not asking for units. And we want to interpret the meaning of that integral divided by 12. So this is essentially going to be the average, the average amount of the average temperature, right? Because this is, we know the formula is for the average temperature, not the average temperature, the average value of a function. That's going to be the integral from a to b of f of x dx divided by b minus a, right? So this is essentially the same thing. So I'm going to write 1 over 12 times the integral from 0 to 12 c of t dt is the average temperature from t equals 0 to t equals 12. So I would put this as my answer, and I'd feel pretty confident. So let's go ahead and move on to question C. For 12, it's less than or equal to t is less than or equal to 20. The rate of change of the temperature of the coffee is modeled by this function here, c prime of t, where c prime of t is measured in degrees Celsius per minute. So they kind of gave you the answer for the first question here. Find the temperature of the coffee at t equals 20, and we want to show the setup for our calculations. So if we want to find the temperature and we're given the rate, we're going to want to integrate. And we have our interval from 12 to 20. So I'm going to integrate from 12 to 20 c prime of t with respect to t. So this would be c of 20 minus c of 12 is equal to some value. And we know c of 12 here, right? C of 12 is 55. So I can replace this as, actually I'm not going to go ahead and write that now. I'm not going to cross out c of 12. So if I plug this very messy integral into my calculator, which I'm going to go ahead and do right now. So negative 24.55 e raised to the 0.01 t divided by t and with respect to t. And I have an answer here of negative 14.671. And we know c of 12 is 55. Let me just write that. And I'm going to write that we got that from the table. And now I know that c of 20 is equal to 55 plus negative 14.67. And if I plug that into my calculator, I get an answer of 40.329. Yeah. So I would put this as my answer, and I feel pretty confident about it. Now, finally, the last part of the question. So it can be shown, for the model defining part C, it can be shown that C prime prime of T, this big thing right here, for 12 is less than T is less than 20, determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate, and give a reason for your answer. So if we want to know if C prime of T is increasing or decreasing, so if C prime of T increases, then C prime prime of T is greater than 0, right? We know that the first derivative will have to be positive if a function is increasing, and if the function is decreasing, then it's going to be the opposite. The second derivative is going to be negative. So let me write vice versa. Vice versa for decreasing. And this is clearly an increasing function, right? Sorry, I'm getting way ahead of myself. I need to go back here. Sorry here, I somehow lost my everything, honestly. So integrate from 12 to 20. Oh wait, no. Okay, I'm really getting confused here. So C prime prime of T is greater than 0, right? So my reasoning is that this is an exponential. It's going to grow very big, right? And it's going to be greater than T squared, right? So C prime prime of T is greater than 0, so therefore increasing. I don't know if the College Board will accept this answer, but honestly, I'm kind of in a time shortage. So I would put this as my answer. And this is it for the first question. So I hope you guys enjoyed this video, and I'll see you soon for the second question.